leaving 1 point. And now I'll show you how to do a dimension. So these 2 points across the head are going to define a dimension we want. We'll go up here, click dimension after selecting those points, and we'll just call that head breadth at ear, say. So some things have happened behind the scenes. One thing is that the value for this particular head has already been computed. And if I change the size of this head, you can see that number updates immediately. We've also automatically computed the 5th and 95th percentile values for the entire population. These dimensions can be isolated to a single axis if we want. So our y-axis is side to side. So we can make that, we can set that to y. So we can already explore the relationships between, so for example, someone who has a narrow head, short and narrow head, someone who has a long head, and you can see how those dimensions change. We can look at the population immediately, though. So say that we're developing glasses and we want to be able to accommodate a large percentage of the head width. Well, we can get that directly off of this plot. I can expand it a little bit for you. So this is a cumulative probability. So I can see that for all the combined population, my 95th percentile is somewhere in this, 165 range, 165.8. And you can see the median and so on. You can see the difference between male and female heads as well. And those actual statistics are down here, broken down by male and female and the combined population. There are many other dimensions. So we already defined one that's here, that's nose width. Let's define a few more just for our subsequent analysis. Let's define one that is the distance between here, the bridge of the nose, and this point back here. And we'll define that only in the fore-aft axis. So the first thing we need to do is select the points, and then we'll create a dimension. And we'll call that ear to nose. Again, you don't need to know the technical terminology for it. You can make your dimension measurement between any points you want. So now a uh, we've got a dimension that measures fore aft on our x-axis, and we can see that for this head we've got 112 millimeters. Let's make a real short head. Now it goes down to 96. We can make a short female head, make a real small female head, and see what that number goes down to. So as low as 92 probably, and of course these are not 100% correlated. We'll look at that in a moment. But you can see that dimension can vary quite a bit. And again, we can look at the cumulative plot. Looks like a large value of that is maybe 115, and a small value of that is probably about 90. So you've got a range of about 25 millimeters that you'd need to accommodate to enable a large percentage of people. Let's move on now. We've covered dimensions. There are, I should say before we leave dimensions, there are quite a few other dimensions that you can compute. You can compute angles. You can compute curved dimensions that arc across the body. And you can also build a dimension from multiple points. So, for example, sometimes it's useful to know the distance from the ear to the mouth. And I can compute that distance by laying in a series of points and turning that into a dimension that sums those. So now let's head over to some of the tabs on the right here. The analysis tab does a lot of useful things. So the first thing is you'll see a scatter plot, and this shows all of the subjects that are in the current database. So when I click on these, I see the actual subject. Now, I want to point out that these are not actual people. These are synthesized heads that we have a statistical procedure we've developed that allows us to de-identify a whole population while preserving the population statistics. So, for example, this distance between these points or from here to here, we can show quantitatively that when you do the analysis on this synthesized population, you get the same numbers that you get if you did it on the real population, but there's no privacy concern. We can do this with our data. We can do it with anybody else's data as well. So you see there's a lot of idiosyncrasy in this data set. There's a lot of variability. Um, and that's just like the real population.